Okay, so we need to get a thing called tangent lines today. Okay? So for this, I need a picture of a function. So I'm going to draw a random function. Okay? Yes?
Yes. Sure.
Okay. Then on my random function, I'm going to put an x on the x-axis. This is really just me denoting somewhere, right? And the thing I'd like to develop here is a way to get a hold of the equation for this blue line. That's what we're going to call a tangent line. You guys cool with this? Okay, so to get an equation for that tangent line, I should remember, I need some things about graphs. So this point here is on the graph of f, right? You guys all see that? Okay, so if it's on the graph for f, what do its coordinates look like? Yeah, they look like x and f of x, right? Okay, and this is a part that might get a little confusing, but I'm going to move over just a little bit off of here. And I'm going to move substantially over on my picture, but I want you to imagine that this over is not very far. You guys see that? I'm going to move over by a distance here that I'm going to call h. Okay? So this is going to be, if this was x and I moved over h, this guy here is, yeah, that's x plus h, right? You guys all see that? Okay, so the point that goes above x plus h is maybe here someplace. And that thing's going to have coordinates that I can calculate. X plus h and f of x plus h. You guys cool with that? I need to feed the x value into the function f, right? And that x value is at x plus h. So that whole thing has to go into my rule f. You guys cool with that? Okay, so right now I'm looking at not the blue line, but the red line that goes through those 2 points. You guys see that? If I moved over just a little tiny distance off of x, the red and the blue line would be close, right? You guys see that? That's really kind of, maybe if I thought about taking this point and dragging it along the graph. You guys see how the red would get kind of closer to the blue as I drag? Okay, so I'm going to start with calculating the slope of the red, and then we'll do something magical. Cool? Okay. So I need the red slope. So what's the slope of that red line? You've got 2 points it goes through. You guys tell me?
F of x minus, f of h of x plus x. I'm glad this is making sense.
Close.
F of x plus h minus f of x. There we go.
F of x plus h minus f of x. You guys all see what he's doing?
Yeah.
It's the slope formula, right? It's the change in y, right? The rise over the run. So I took the rise, right? I took the y coordinate for the second point, subtracted the y coordinate for the first point. That'd be rise. And then I should
Do
X plus h minus x.
yeah, so this should be over x plus h minus x, right? You guys all see this?
For the bottom, just put h.
Oh yeah, and then the bottom really is just h, right? You guys see that on the picture? You guys see how we kind of engineered that already on the picture? I said I was going to move over a little bit, right? That meant I was going to run just a little bit. You guys see that? So I set up the run of h. That was kind of in there already. So I can reduce this a little bit. I can get f of x plus h minus f of x all over h. You guys cool with this?
Yeah.
Okay. So now what we need to do is we need to get the slope of the blue line. You guys see that? So what would if I wrote down slope of the blue line, right? How would I think about this? This is the slope of the tangent line, right? You guys see that? For sure? Okay, so if that's the slope of the tangent line, well, it's almost this red thing, right? You guys see that? So this slope is maybe not exactly equal to, but almost equal to that thing. You guys see that? How can I make this approximation better? What do I want to do to h to make that approximation closer? On the picture, what do you do to this point here, right? Maybe think about this as your anchor point. What do you need to do to that point to get the red line slope closer to the blue line slope?
Get rid of the distance.
Yeah, I want to make this distance go away, right? You guys see that? Like here's the red slope. If I move my purple point to here, right? You guys see that? My new red slope would be going through there. That would be closer, right? You guys see that? Then if I move that purple slope even closer yet, right? Or that purple point even closer yet, I'd get an even better slope. You guys see that? You guys remember the tool that we used to do this? To move things like this? What, are you guys not a calculus class? Oh, you guys you don't know the tools to limit? Because you send h to 0 with it? That's totally unfamiliar in here? Oh shit, did I play an April Fool's joke on you? This is about halfway through the first month of calculus. Say hi. You got me, I will admit that. So you can scrap all of this. But in point of fact, all of you were totally with me until I started pulling h to 0. Weren't you?
Yes.
That's super.
The whole time.
No, you weren't.
Yes, I was. No, it's just the whole fucking.
Isabel's like, no, you weren't.
You were. I was. I didn't cry. I was like, I'm gonna fail.
I know, and then you asked me a question, and I said no.